Students, now we are going to learn about measuring skewness. We have seen in the previous class what is skewness. Now how to measure the skewness. One is observation method, the second one is statistical method. We'll see what is observation method. That is a simple method. There is a simple method of deducting the direction of skewness by the inspection of frequency polygon prepared on the basis of the scores. So using the scores, you can prepare the frequency polygon, and that polygon, if you draw the curve, which direction it is bending, maybe left side or right side. Using that, you can find the skewness. What is the trait of the population and how the sample is drawn? Looking at the traits of the frequency polygon of the distribution obtained, if the longer tail of the curve is towards the higher value or upper side or right side, if it is bending towards the right side to the center or mean, the skewness is positive. If the longer tail is towards the lower value or lower side or left to the mean, okay, if it is bending to the left of the mean, the skewness is negative. This is only approximate method. You can call it a crude method. Then if you want to measure, you have to use a statistical method. So to know the skewness in the distribution, we may also use statistical method. For the purpose, we use a measure of central tendency, specifically mean and median values. Because using the mean and median values, we can find the skewness. Mean is which side? Mean is higher or median is higher? That gives an idea. Sk equal to 3 times mean minus median by sigma. So you should remember this formula, 3 times mean minus median by sigma. Another measure of skewness based on the percentile value. That is Sk equal to P90 minus P10 by 2 minus P50. So using these two statistical formulas, we can find the skewness. Same way, measuring the kurtosis also, there are two methods. One is observation method, another one is the statistical method. For judging whether the distribution lacks normal symmetry or peakness. If the peakness is too high than normal or below the normal, so it may be deducted by same way like we did for the skewness, kurtosis also using the frequency polygon. If the peak of the curve is thin and sides are narrow, you can see that the sides are narrow, it is very close to the center. Okay, and the sides, if you see left side and right side, they are very packed and close to the center, and the distribution will be the leptokurtic. If the peak of the frequency distribution is flat, far away from the center, and the sides of the curve are deviating from the center, that is, it is moving away from the center, then we call that curve is platykurtic. It is a flat type towards plus or minus 4 sigma and plus or minus 5 sigma, then the distribution is platykurtic. Statistical method to find the kurtosis using the formula. Kurtosis can be measured by following formula: Ku equal to Q by P90 minus P10. Q is nothing but our quartile deviation, P10 10th percentile, and P90 is the 90th percentile. A normal distribution has kurtosis 0.263 that we have seen before. If the calculated value of Ku is less than 0.263, that is Ku is less than 0.263, the distribution is leptokurtic. And if Ku is greater than 0.263, then the distribution is platykurtic.